In this video, we will start becoming familiar with serverless cloud architecture and be introduced to a basic serverless application running on AWS. We'll also be introduced to Serverless Framework for managing a serverless application. Serverless Framework will help you develop, deploy, and debug your serverless application. Our objectives today are to understand a basic serverless application, as in what it looks like and how it functions, and become familiar with using Serverless Framework. These basic objectives are intended to provide you with both a beginning understanding of serverless architecture, familiarity with one of the tools in the space, and help enable you in your own exploration after this video. To achieve our objectives, what we will do is deploy a serverless application, use the application, and trail application logs to see it function. Our application is called Wild Rides. It's a ride request service that sees beyond taxis, autonomous vehicles, and scooters and uses unicorns instead. The code for this is available on GitHub. Here's how the application works in practice. Scroll and click Giddy Up. This will bring you to the ride request page. On this page, right-click to place your pickup location, and then in the upper right corner, click Request Ride. You'll see a unicorn fly in to fetch you. This is what our serverless application looks like. It's a three-tier architecture composed of a front-end, back-end, and data layer. All three tiers are coupled together into a single deployable application, making this a monolithic as opposed to microservices architecture. The front end is hosted on and served by S3. The back end is a combination of API Gateway and AWS Lambda, and the data layer is a DynamoDB table. Contrast that with what the application might look like running as host on EC2. Here we have EC2 instances in autoscaling groups. Both the backend and front-end instances are running a web server, such as Apache or Nginx. The data layer is host instances running MongoDB. In our serverless application, the user views the site served up from S3. All static assets such as HTML, images, client-side JavaScript, etc. are stored here. When they request a ride from the site, a web request is made to an API Gateway endpoint, which triggers a Lambda function. That function requests a unicorn from DynamoDB, and that information is returned to the user. By the way, the application does have some extra resources, such as functions to manage configuration and an S3 bucket for storing application configuration. You'll see them as we deploy the app, but we're going to ignore them until later lessons. To deploy the application, we will install Serverless Framework, deploy the application, and navigate to the website. We'll start by installing Serverless Framework. This is a tool that helps you to manage the entire lifecycle of your serverless application from development to deployment. To install, type npm install-g serverless. Once it has successfully installed, type serverless-help to get the tool's help. You might also instead type SLS, which is short for the serverless command. I will typically use that shortcut. Next, we need to install the serverless plugins for this application. Type npm install. This will install the additional plugins that our application relies on for Serverless Framework. To deploy the application, type sls deploy-v. It's now collecting the Python dependencies required for the application, and it's creating the initial AWS CloudFormation stack for deployment. It has just created the AWS Lambda artifact as well, and it's now creating the resources in AWS for the application, such as S3 buckets, DynamoDB tables, etc. It's just finished creating all the AWS resources required for the application and is now syncing the static website files up to the S3 bucket, which the website will be served out of. Now that the application has finished deploying, see down here in the stack outputs for static site S3 bucket website URL. This is the URL of our newly deployed application. Scroll down to where it says Giddy Up and click. Click anywhere on the map to set a pickup point, and then click Request Unicorn. There we go. This is our application. We'll now observe a serverless application in action. That is to say, we'll see the effect of clicking Request Ride. To do this, we'll also introduce the logs and invoke commands of Serverless Framework. We're going to trail the request ride function's CloudWatch logs using Serverless Framework. And then we'll see how to use it to manually invoke the function without going through the front end at all. These commands will be highly useful as you debug future serverless applications, either during development or even in production. We're going to start with function logging. Every AWS Lambda function invocation results in log messages being written to CloudWatch. These are messages that indicate the start, end, and resource consumption of the invocation. Additionally, anything you log within your code to standard out will end up in CloudWatch as well. To start, get the name of the function. Type SLS info. Here in the function section, it's called request ride. To trail Lambda function logs, we use Serverless Framework's logs command. Type SLS logs -- help to see what this command can do. You'll see the function's argument is required. We're also going to use the tail argument so it continuously pulls for more log messages. On the left, we have wild rides, and on the right, we have our terminal window. To tail request rides logs type SLS logs -f request ride -t. Now we request a ride. On the right, we will see log messages beginning to appear. There will be a delay in logs appearing. The reasons for this are twofold. One, there is latency between when a Lambda function fires and data appears in CloudWatch. And two, Serverless Framework is polling periodically for more log messages. It polls by default every 1,000 milliseconds. The first line we see is a start log message. This lets us know where an invocation request begins. A few lines down, we have an end message. This tells us where the function invocation has ended. The next line is a summary message that tells us the duration, the build duration, because AWS Lambda rounds up to the nearest 100 milliseconds, the requested function memory, as well as the actual memory consumed during the invocation. These messages are printed on every invocation regardless of how you have configured your function to log. In between the informational messages are messages we've logged via our function code. In our functions code, we initialize a logger, and down here in the handler, we log the invocation event and the response the function returns. What we just did was use wild rides in order to invoke request ride. But what if we just wanted to invoke the function without going through the front end? You may eventually encounter applications of such complexity that trying to use it to debug a function just isn't feasible. In those cases, Serverless Framework's invoke command is useful. This command lets you invoke a function directly. To invoke a Lambda function, type SLS invoke -- help to see what this command can do. You'll see the function's argument is required. We're also going to use the path argument, which will be the path to a file containing an invocation event. On the left, we're trailing the request ride function's logs. On the right, we're going to invoke the function with a test event. What we get back on the right is the response the Lambda function would return to API Gateway. It has an HTTP status code, body, and headers. On the left, we'll see the function's logs start to appear. Finally, we're going to remove the application. To remove the application, type SLS remove -v. It'll remove the static web assets from the S3 bucket, and now it'll start removing the AWS resources in the CloudFormation stack. And now, Wild Rides has been removed. What we've just gone through is a demonstration of a basic serverless web application. All this should provide you with a basic understanding of serverless architecture and familiarity with a common tool. The Wild Rides application demonstrates how to build a functional web app without the need for managing any host instances. We've also been introduced to the basics of Serverless Framework. We've seen how to deploy, trail logs, invoke a function, and remove our application. Learning and understanding these basics will help you to begin exploring on your own.